Hi, this is question number 8 from the AQA Mechanics 2 June 2015 exam paper. In this question we have Carol, who's a bungee jumper of mass 70 kilograms, and she's attached to one end of a light elastic cord. And so I'm just going to get my highlighter. So she's a mass 70 kilograms, and the cord has a natural length of 26 meters and a modulus of elasticity of 1456 newtons. The other end of the cord is attached to a fixed horizontal platform which has a height of 69 meters above the ground. Carol steps off the platform at a point where the cord is attached and falls vertically, and we're going to assume hook laws applied, and there's she's going to be treated as a particle and air resistance is negligible, and we're being told that when Carol has fallen x meters, her speed is v meters per second. Now for part A, we're being asked to consider energy to show that this equation is true for when x is greater than or equal to 26. Okay, so we're going to start by drawing a diagram. So I've started drawing a diagram over here. This is our cliff, and it's a height of 69 meters, and Carol is at the top of our cliff over here. So here's Carol, little stick Carol over here, and she is about to jump off the cliff, and her bungee jump, which I'm going to her cord, which I'll draw the dotted line in red, has got a natural length of 26 meters, so I'll draw it to about that. Okay, and we're trying to find when Carol has fallen x meters, but we're told over here x is greater than or equal to 26. So I'll draw it in a different colour. So this is Carol once her bungee has stretched, and we know that it's going to be longer than this line over here. So I'm just going to label some distances over here. So this distance here is going to be 26 meters, and I'm also going to label this distance here. Okay, so that's how far away from the ground she is, and that's going to be 69 take away 26, so that's going to be 43 meters. Okay, and I'm also going to label this distance here. Okay, so this distance is going to be, well, she's fallen x meters, so we're going to call this distance here x meters, and this distance here from the ground up is going to be 69 take away x meters. Okay, so it's 69 in total. 69 take away x is going to tell us that distance there. Okay, and I'm going to take, let's do this. So I'm going to take this here to be my reference point for my potential energy. So I'm going to say over here mgh is equal to 0. Okay, so now we've got our diagram. We can have a go at answering part A of this question. So we're going to consider energy to show that that is true. Okay, so I'm going to start by deciding how much energy is in my system here. So the so at the top we can say, well, my total mechanical energy at my top is going to be equal to it'll be mgh, which is going to be, it's got a height of 69, and mass of 70. So we've got 70 times 69 times G. So that's the MGH plus our kinetic energy, which is going to be 0, and our elastic potential energy, which is also going to be 0. So we're just going to have that there. So at the top, my mechanical energy is going to be 70 times 69, which is 4,830 G. 4,830 G. Okay, so that's what we've got at the top. Now, because we know that Carol has fallen X meters, we're now going to find out how much energy we've got at this particular point here, which is fallen X meters. So at X meters, right, so our mechanical energy now is going to be equal to, well, we've got MGH again, so our height is going to be 69 take away X. So we've got 70 times 69 take away X G, so that's our MGH bit, and then plus any kinetic energy that we've got. So our kinetic energy is going to be half mv squared, and m is 70, so we're going to have 35 v squared, and we need to add on our elastic potential energy. I'll just write that over here, which is going to be equal to lambda E squared over 2L. So a lambda, we know our modulus of elasticity is 1456 newtons, and we need to times that by our extension squared. So our extension is going to be this distance here. Okay, that's our extension. So we've got, if all of this is X and that bit there is 26, this bit here must be X take away 26 meters. Okay, so we're going to times that by X take away 26 squared. Okay, I'm just going to clarify that again. We have it's been stretched up to a point of X meters, and its natural length was 26 meters. So how much it's extended by, our extension E, is going to be this whole X subtract that 26. So that's where that X take away 26 comes from. X take away 26 squared divided by 2L. So 2 times our natural length, it's going to be 2 times 26, which is 52. Okay, so that's what our energy is going to be at X. So there's not been any energy loss here because we're assuming that there's no air resistance. So this must be equal to what we had over here, which is 4,830 G. So I can say that 4,830 G is going to be equal to 70 times 69 times G. So I'm just going to expand this out. 70 times 69 times G is going to be 4,830 G again. We worked that out earlier. And then 70 times X times G is just going to be take away 70 X G. Okay, plus 35 V squared. And then let's work out 1456 divided by 52, and that's 28. So we're going to have plus 28 X take away 26 squared, and if I expand that, I've got X squared take away 52 X plus 26 squared, which is 676. 676. Okay, so if we tidy this up a little bit, these are going to cancel out with each other, so I can say 0 is going to be equal to negative 70gx plus 35v squared plus 28x squared, take away 52x plus 676. Okay, and all of these are divisible by 7. So I've got 0 is equal to negative 10gx plus 5v squared plus 4, and I'll expand this bracket now, so we've got 4x squared, take away 208x, and then 4 times 676 is 2704. Okay, and we can tidy this up. So I've got this 5v squared and I want that to be on my left hand side, so let's bring 5v squared over here, and that's going to be equal to, and we're going to have negative 4x squared plus 10gx plus 208x, take away 2704, and that tells me that 5v squared is going to be equal to negative 4x squared, 98x, so 10 times gravity is going to be 98x plus 208x. So we've got 98 plus 208, that gives us 306. Take away 2704, which is what we require over here. I've written it in a slightly different order, so it's 306x, take away 4x squared, take away 2704. Okay, so that's part A done, and I'm just going to tidy this up a little bit before we move on to part B. Okay, I just want to note that I've actually written it in the same way that they've got it over here at the bottom there, just to make sure that I get the marks. There's no point taking any chances. Now in part B, where being asked to explain why the expression found in part A is not true when x takes values less than 26. So if x is less than 26, that means that the rope won't yet be extended, or it won't be taut, in which case our elastic potential energy won't apply. So B, we would say when x is less than 26, then rope not taut, therefore EPE does not apply. Okay, and that's enough for a mark there. Okay, for part C it says find the minimum value of x. In fact, it says find the maximum value of x. So in order for x to be at its maximum point, it's going to be when our velocity is momentarily 0. So velocity will get to a value of 0 before it starts moving up again. So for part C, we want our velocity to be equal to 0. So we can use this expression, but we're going to say v is equal to 0, therefore 0 is equal to 306 x take away 4x squared take away 2704. And I'll just come over here and okay, and I'm just going to write that in a different order. We'll say that 4x squared take away 306x plus 2704 is equal to 0. Now I can use a quadratic formula to solve this. I'm actually going to cheat a little bit here. I'm going to use my calculator. So let's go to mode, equation number 3, and if you haven't got a calculator like this, you can just use a quadratic formula. So let's say we've got a is 4, b is negative 306, and c is 2704. Okay, and we should get 2 results for this. We've got one result where x is equal to 66.3, so I can say that x is equal to 66.3 meters, and the other solution is x is equal to 10.2 meters. Now, bearing in mind we said that this is only true for when x is greater than or equal to 26, we can disregard this solution. We've only got one solution where x is equal to 66.3 meters. Okay, so that's part C. Part D. Okay, so for part D, it says find the distance fallen by Carol when her speed is a maximum. So her speed is going to be a maximum from when our acceleration is going to be equal to 0. Yeah, so we have a maximum speed when the acceleration is equal to 0. So I can say that I know that my acceleration is going to be equal to 0. So if my acceleration is going to be equal to 0, momentarily this system is going to be in equilibrium. So that means that if I label on certain forces here, I've got in this rope, I'm going to have a tension going this way, and then I'm going to have my weight going over here. So I've got my tension going up and my weight coming down. And when this is momentarily in equilibrium, when the acceleration is equal to 0, then t is going to be equal to mg. Okay, now t is going to be the tension in the rope, which by Hooke's law is going to be lambda e over L. So my modulus of elasticity times by the extension divided by the natural length. So let's pop that over here. Lambda e over L is going to be equal to mg. And we can plug in our values now. We know 1456. And we know that E is given by x take away 26 over L, which is 26, and that's going to be equal to the mass times gravity, which is 70 g. Okay, so I'm just going to put this into my calculator to work out x. So we've got 70 times 9.8, that's 70 g, and I'm going to times that by 26 and then divide by the 1456. And so that's going to tell me what x take away 26 is, and then if I add 26 to that, this should tell me what x is, and I make it x is equal to 38.25. Okay, you should write down your steps here, and you might want to rearrange that. First for x, but I've run out of space, so I'm just going to whack it in there. 38.25 meters. Okay, so that's going to be the distance fallen by Carol when her speed is maximum. For part 2, we need to work out what Carol's maximum speed actually is. Okay, so we've got this equation here that will tell us the speed if we plug in the x value, and we know our x is 38.25, so I can just stick that into here. So that means that I can work out 5v squared, because that's going to be equal to, so it's 38.25, my stored answer, and I'll do 306 times my answer, take away 4 times my answer squared, take away 2704. Okay, remember that answer's just stored in as 38.25, and that equals 3148.25. Okay, and then so that's what 5v squared is, so I need to divide that by 5 and then square root my answer, and I get 25.1. so v is equal to 25.1 meters per second, and that there is going to be what Carol's maximum speed is. Okay, I hope you found that useful. Thanks very much for joining me. I'll see you next time.